Marvelous. How are we doing? Didn't, woo! Woo! Well, that day went quite quickly, didn't it? I can't believe it. So, this morning, I was talking about complexity. I was talking about you looking out into the world. Now I want to talk about you. And in particular, I want to talk about who are the developers. Put your hands up if you're a developer. Put your hands up if you're not a developer. Okay, this applies to you as well. You might need to change some of the words. Okay, so I want to go way, way back to the prehistory of time, right? To the prehistory of computing. Way back to the Old Testament. Okay, so in the beginning, this is 1844. So not actually the Old Testament. 1844. This is all the code in the world. Does anyone know what this is? Does anyone recognize this? Has anyone seen this before? No? Okay. So this was this was the first ever, what's considered the first ever algorithm for a computer that was written down. It was written down by a lady called Ada, Countess of Lovelace, who was the daughter of Lord Byron, who was an English poet and druggie. And his wife was convinced that his daughter, Ada, wasn't going to grow up to be a druggie and a poet, and so she taught her science and mathematics and was an all-round excellent mother. And she had an external tutor who was another amazing woman of science. So this was... Lovelace was working with a chap called Charles Babbage, who had designed a thing that was called an analytical engine. He'd figured out a way to build a thing that we would now consider a computer. And he was working with a chap, an Italian guy, who had written to him in French, I think. And so Ada spoke both French and Italian because she was pretty smart. And so he said, look, can you translate this? And so she translates these notes from this Italian chap. And she famously wrote down a series of notes of her interpretation of what he was saying. And of course, her interpretation of what he was saying was far, far more interesting than what he was saying. And in particular, this is note G. And note G, this thing here, is an algorithm for calculating Bernoulli numbers. Okay, for getting a computer to calculate Bernoulli numbers in 1844. That's pretty cool. Okay, you'll also notice there's no tests. Okay, that came later, right? But so this is all of the code in the world. This is all the programmers in the world. Okay, so this is Ada, Countess of Lovelace. Mary Somerville was her tutor. And Mary Somerville is another amazing 19th century woman. She was the woman about whom the word scientist was invented. Okay, so before Mary Somerville, we had men of science. So if you studied science, you were a man of science. And this woman was doing really cool stuff. And they said, we can't really call you a man of science. That doesn't work. So they invented the word scientist to describe Mary. So this is all of the computers. So what this tells me is, A, all the programmers in the world were female, and also they really knew how to dress, right? I'm looking around at a room full of people in jeans and going, that's how you should dress if you're coding. Okay. So 100 years later, then, does anyone recognize this? I'll be surprised if anyone recognizes this. It's from a 1980s computer game called The Hobbit. And you would type in things at a command line like go north, and it says you go north. And you'd meet Thorin, and Thorin says hello, and you say hello. And if you wait, Thorin waits as well, which is quite sweet. So you says wait, you wait, time passes, Thorin waits, which is quite nice, because Thorin doesn't just walk off and leave you. Anyway, so time passes, 100 years later, things have gotten a bit serious. Okay, so now it's 1944, and this is the Second World War. And this is programmers hacking on a computer, literally hacking. Because what they're doing is they're cracking the Lorentz cipher, which was the computational bit inside the Enigma machine. And again, so we've got these two women, and they're programming a computer by moving things around in the computer. Okay. According to Wikipedia, their names are Dorothy Dubuisson and Elsie Booker. And they're busy working on a Colossus Mark II, which was invented by the military to crack these ciphers. And so necessity is the mother of invention. So this is one of my heroes. This is Admiral Grace Hopper. She invented the compiler. She invented the compiler because we needed a compiler. We didn't have one. There's a lovely interview with her, and there's this guy, I think it's it's one of these sort of American evening talk shows, and he says, well, so you were running this computer program because you were the world expert in computers. And she said, no, there weren't any experts in computers. We were making it up. We had to invent it. She also invented the nanosecond. Well, she didn't invent the nanosecond, but what she did, she was trying to explain to a bunch of admirals in the army about how communication worked. And so they couldn't understand that communication wasn't instantaneous. And so she said, OK, here's the thing. So she phoned down to the machine room, and she got them to cut her a number of lengths of wire about this long. And she'd wear them around her neck. And she'd be in a meeting, and she'd say, here, have a nanosecond. Right, have a nanosecond. And what do you mean, have a nanosecond? And she said, well, look, this length of wire represents how far light travels in a nanosecond. Okay? So if you want to get a message to a ship, start here and think of how many nanoseconds you have to unroll to get up to the ionosphere. Same number of nanoseconds all the way back to the ship, then some more nanoseconds going through. That's the shortest possible message time you can have. And they went, oh. She also had some microseconds, but they were much longer. So you had this big coil of wire. Very, very amazing woman, Admiral Grace Hopper. And so now what happens is we bring it forward a bit, and now in the 60s, people begin to specialize. And so what's happened now is we've made computing so easy, even men can do it. Okay? So here's some men, and they're debugging. And in fact, look, they're pair programming, which is nice. So early pairing. And so back in the day now, we've got commandments, okay? So there's lots of commandments. Things like, thou shalt have business requirements document. Okay, you shall have a functional specification. You shall program in the manner of the specification. You shall have no other specification before me. Okay, analysts shall analyze, architects shall architect, programmers shall program, testers shall test. So we've all got our different specialisms, and that's what we do. We work in our little silos. And there's more commandments. You shall complete a formal change request. Okay, if you want to get anything into production, right? Thou shalt provide release documentation. You should not release to production yourself, lest you incur the wrath of the release manager. Okay? You shall not hack on that which is in production, which is more of a guideline, really. Okay. And so then what happened in about 2001, the New Testament. Okay, so what's the New Testament? The New Testament is this. This is, some of you will recognize this picture. This is a photo or an image of a photo of 17 middle-aged white guys standing around a screen. Okay, so this was in Utah at a place called Snowbird, a skiing resort. I'm going to go there this year. I'm going to do a little pilgrimage to Utah. And so what happened was this bunch of guys all came together because they all had something in common. They were all successful software people. And they were all kind of getting work done. And the guy that brought them all together, Robert Martin, he said, look, we've got a lot more in common than we have different. So they all had their different brands, but basically there was a bunch of things they had in common. And so they spent a weekend thinking about this, and they drafted this famous Agile Manifesto. Has anyone not seen the Agile Manifesto? Right, that's cool. Okay, a couple of hands that haven't seen the Agile Manifesto. So this is a bunch of statements about values, and this changed a lot of things. Who's been in technology, in IT, for less than 15 years? You've been doing this for less than 15 years. See your hands right up in the air. Yeah. Okay. For you, Agile has always existed. There's never been a time when there wasn't an Agile Manifesto, okay, in your career. So they said some quite outrageous things. They said that individuals and interactions are more important than processes and tools. People misunderstand this document a lot. What they're saying is this: everything on the right here, okay, all of these things. Oh, hello. Let's go back. Ah. Nope. Okay. All the things on the right are valuable. They wouldn't even be on the page if they weren't valuable. We value processes and tools. We value documentation. We value having a plan. We just think the stuff on the right's a bit more important, and that's why it's in bold. That's all. Right? Nothing on there isn't important. All the not important stuff's on the floor, We don't care about that. So everything on here is important. There's just different priorities. And so this started to change a lot about how we do work. In particular, we came out of our silos and we started creating these cross-functional teams. And we started having much more interactions in our daily working life. And it kind of changed a few things. And so then, revelation, right? We have to start thinking differently. We have to start thinking beyond developer. So now I start thinking of myself as a multi-dimensional creature, okay? So I am a developer, okay? I'm a developer and I'm in a team. I'm not on my own anymore, and I'm not sitting with a bunch of other developers. I'm sitting with people who are all part of a product team. I might be sitting with testers and analysts and all kinds of other cross-functional, multidiscipline people. I'm building a product, okay? I'm not just turning requirements into code, which is what I used to do. I feel like I'm building a product. I feel a sense of ownership there. And that product doesn't live in isolation. If I'm working in Roche or I'm working in a big company with lots of existing stuff, then I'm building on a platform that already exists. Okay? And again, my team isn't in isolation. We're in a department. Okay? So there's an organization around us, and finally that department is part of an organization. So suddenly, immediately, I'm this six-dimensional thing. There's at least 6 dimensions of me that are interesting. But this isn't about me. This is about you. Okay? And so what I want to do is spend a little while unpacking each of these and thinking about what it means to be a developer in the modern age. So let's just start off with this. So you're a developer. What does that mean? That means, well, clearly you need to know the language, right? Whatever languages you're programming in, you have to know the basics of the languages, okay? But the syntax and the words and the rules of the language and the language spec, that's typically the easiest thing. You can pick up a new language in a couple of days. That's not hard at all. The thing you really need to know is the libraries, right? Is how did the people who designed the language and the core libraries figure that stuff out? So Java as a language, pretty easy to learn. Java, the core libraries, there are still libraries. I've been using Java for 20 years. There are still libraries in Java I've never used, okay? I don't know them. There's whole areas of Java that I've never done anything in Java FX. And I'm still happy. I'm still a functional human being. It's fine. It's fine. The Java FX police don't know where I live, which is quite nice. But so you need to learn the libraries. It's not enough to just know the language. But also, you need to monitor the alternatives. You need to know what other things are out there. A lot of the technologies we're using now are insanely fast-moving. Anyone who's doing stuff in Java or in JavaScript, there's a thing on the internet, you know, days since last JavaScript front-end library. And they keep scrubbing it out and going to 0 again, you know. And then, like, not just React, but like flavors of React, or not just, you know, virtual DOM-based, whatever. So Adam's lovely talk earlier on about the different web technologies. I thought by the end of this talk, that will be out of date. Right? By the time he finishes speaking, a new thing will have happened. Yeah. So things are moving very quickly, so we need to monitor the alternatives. It's very easy to get institutionalized, especially when you work inside a big organization on what you're doing. And again, we're not just writing code and throwing it over the wall. We're part of a holistic team doing work, so we need to understand our tool chain. How do we build stuff? How do we deploy stuff? How do we test stuff? How do we monitor stuff? How do we manage the code? How do we manage the application? So understanding the tool chain is really important. And we're not living in a bubble. We're not building code in a bubble. And so we need to engage with the community. So again, the 2 lovely talks that preceded mine now, I was just sitting at the front grinning, right? So you've got someone who's decided they're going to get up and get out there and start blogging, and he's writing down things, and he's doing it with no, you know, someone said, are you going to monetize this? No, I don't want to make money out of this. I want to have fun. I want to learn. I want to share my knowledge. So his entire motivation is sharing knowledge. That makes me happy. And then the lady that followed him, so she started trying to learn some stuff, and then she said, and then someone said to her, you realize you know enough to do a PhD in this. And she went, oh. Accidentally doing a PhD is something I've never heard of. Right? That's pretty awesome. That's a self-starter right there. So engaging with the community, getting out there, sharing knowledge, because you'll grow, you'll learn, and you start to contribute back. We've got 2 Java champions here. That makes me happy. That makes me smile. So that's you as a developer, okay? But now you're in a team, Okay, so you're not there in isolation. So what does this mean? This means that you need to understand the software process, the process of building a product, the process of building software. And you need to understand where you fit in that, and you need to understand where your team members fit into that. You need to understand the various roles in the team and the various responsibilities. Who can you lean on for different things? Even if you have a number of programmers in a team, the chances are different people will be good at different things, or better at different things, or prefer different things. Conversely, people don't like doing certain things. Okay, and so that means, if there's some work coming up, one guy I was in a team with, we were building trading applications, and they were being managed in a browser. And this was at a time when people weren't building trading apps in a browser. It was always in C# or Java, and thick clients on the desktop, and we were using a browser, which was a bit crazy, but it kind of worked. And this one guy, fantastic finance brain, really understood financial modeling, rubbish at web design. And so what he would do is, rather than try and design good-looking web pages, he'd design deliberately ugly-looking web pages. Because then another guy in the team would go, oh, that's so ugly, I have to fix it. And so that's how the pages ended up looking good, is that this one guy, Phil, would make really ugly pages, and then this other guy, Neil, would come along and just make them look gorgeous. And then Phil would go, yeah, that's fine, let's ship that. Yeah, and so they were kind of leaning on each other's strengths, and that worked really well. You need to play. You need to collaborate with other people, okay? So this is you're no longer sitting there with your noise-cancelling headphones on, and every time someone comes near you kind of shrug like that, and scare them off, yeah? You need to start collaborating with people, okay? All the people, okay? So not just your favorites, right? And not just within the team, right? Maybe other people outside of the team as well. I was talking to a chap earlier on who's a business analyst, and he says, well, my job is to stand between the stakeholders and the development team. And I was like, that's true. I would be much happier if your job was to enable communication between those two groups of people. That would make me really happy, because now we've got a much shorter lead time, a much shorter path between the people with the need and the people meeting the need. And then the business analyst role in the new world is as a facilitator, a communicator, a subject matter expert, a fount of information. I'd much rather have what's in your head than a good-looking document every time. Thank you. You're very welcome. And also that you attend to the team's health. Okay, so if someone is feeling flat, don't just kind of, oh, well, that's their own personal stuff because we're all here as robots writing code. That's not what we do. We look out for each other. Okay, if someone seems a little bit distracted, it's probably because they've got other stuff going on. Cut them some slack. See if you can help them. And then if you offer to help them and they say, no, go away, respect that they said, no, go away, which is sometimes quite difficult. Yeah? Be aware that you have needs. And if you yourself have needs, don't be afraid to ask your team, hey team, I'm having a really flat day today. I don't know why, I'm just feeling. And your team looks after you. People find that enormously difficult. It's called vulnerability. Making yourself vulnerable is very, very difficult for a lot of people, because especially at school, we're told, if you work with someone else at school, they call it cheating. Okay? If you don't work with someone else at work, they call it not collaborating. It's really hard, this life thing. Yeah. So, at school, we don't really work in teams. At college, we don't really work in teams unless we're doing a project and then we're looking out for each other because we want to get the most points. Yeah. It's still a bunch of individuals. When you're working in a team, it's genuine collaboration, attending to the team's health. Okay. What else? Well, we're building a product. So what does that mean? Well, that means that now I need to start being aware of the work I'm doing. Again, in the old world, when I was starting out programming, you would get a big, thick functional specification. Well, you'd have a business requirements document, a BRD. That would then become a technical specification. That would become a detailed functional specification, and you would be given a chapter of the detailed functional specification. And your job was to turn a list of requirements into code. That was it, and throw it over to some testers who then, their job was to take code and turn it into bug reports. Okay? And then your job was to hate the testers. Right? And then the tester's job was to go, we don't care. Yeah. So we're in separate silos. Now you need to think about the fact that you're building a product. Yeah, I've been seeing some amazing innovative things. If you're in the expo area, people using like devices and Bluetooth controlled devices to manage conditions like diabetes and asthma and stuff. I'm an asthmatic, And a couple of friends of mine in the UK are building a startup. They're 3 years into building a startup about managing diabetes. So both of these things are things I really care about. And I'm seeing great innovation going on. That's exciting. And so if I'm a programmer, I can engage with that. So what does that mean? That means I need to understand what it is I'm out to do. I mean, I need to understand my business objective. If I can do that, I can get excited about it. And often it means I can be creative about different solutions. If someone says, do X, I go, oh, okay, I'll just go and do X. If someone says, can you solve Y, I think a good way to do that is to do X. Well, I can think of a better way to do that, which is some other thing that you didn't think of. It's actually called commander's intent. So this is an army thing. They call it the commander's intent. So the way the modern army works is not command and control. Okay, that stopped in like the late 1800s. What we have now is a model called commander's intent. And that is this, is I say to someone, I say, right, now I need you to go out and do this thing for this reason. So I say, I need you to, there's a hill and there's some bad guys on the top of the hill, and we need to neutralize the hill so that we can get some supplies to the hospital that's the other side of the hill. And you say, okay, so now you know what we need to do. We need to neutralize the hill. And you know why, because we want to get the supplies to the hospital. And I say, what are you going to need? And you tell me, and you say, I'm going to need this many men and this much supplies and whatever else. And so then in you go. And then when you go in, you suddenly realize when you get close to the hill that it's much more heavily guarded, heavily fortified than you realized. And if you go running up there, that's suicide. You go, oh, that's a bit crazy. But there's only one road coming down the hill. And so what you do instead is you mine the road and you blow up the road. So now you've trapped all the bad guys at the top of the hill. They're stuck. And no loss of life, right? And you knew that that was a good thing to do because you knew why you were doing it, because you were trying to get the stuff to the hospital. So the trucks go through to the hospital and everything's fine. So you can change your plan on the ground because you understand what the intent is. And that model of trusting people to figure out what the right solution is really powerful. You need to study the domain. I mean, we just heard a wonderful, wonderful talk about studying the domain. I am a programmer. I am doing bioinformatics. I'd better go and clue up. Or I'd better go and clue up so one day we're going to call her doctor, okay, which is kind of cool. But, she's really, really taken to heart that actually in order to be able to contribute to the healthcare domain, she needs to go learn the healthcare domain. I've worked in lots of different domains, and I know lots of domains a little bit. I know people who've studied a particular domain, like maybe their whole life, and become very, very, very knowledgeable in that domain. That means they can solve problems I'm simply not able to. I'm not qualified to. Okay, so bother learning the domain. Go learn the domain, and go and make friends with the people who you're building this stuff for. Know your stakeholders. Okay, if you know your stakeholders, you can understand what they're really saying. They say, oh, I want this. Henry Ford, famously, he didn't say this, but it's apocryphal. It's said that he said this. If I had asked people what they wanted, they would have said faster horses. Okay, so he invented the combustion engine car. And he said, no, people would have asked for faster horses, because what people do is they take what they already have and they have a delta. So they say, oh, a horse-drawn carriage, I want a faster horse-drawn carriage. They don't think, I don't want horses at all. Can we reimagine travel without horses at all? Steve Jobs used to say this as well. He said, the last person you ask is the users. Right? They have no idea what to build. They know what the need is. When I show them, they say, yes, that's exactly what I meant, but don't ask them. Okay? So this is why we have product managers and people who think in terms of product and designers. But understanding the stakeholders means you can start to empathize with them. And all the stakeholders, right? Not just the ones you like. Right? And also, not just the users. They're not the only stakeholders. So you've got the end users are the stakeholders, the people paying for it, the sponsors, they're stakeholders. But we're talking software here, and this software is going to be running in an environment, and it's going to be looked after by people. So your operations team are stakeholders. Your support, your first, second, third line support are stakeholders. Your compliance are stakeholders. Security are stakeholders. In this industry, regulatory and compliance are stakeholders. We need to go and speak to all those people as well. I was working with a healthcare company in Germany about 10 years ago now. And they build, they do really cool stuff like MRI scanners, CT scanners, all that kind of thing. And they build the physical things, and they build all the kind of the imaging software and everything. And I met their head of regulatory. Her name's Dr. Vera something. A very serious, stern German lady. And I said, so what do you do? And she said, she didn't say, I make sure that we meet all of the regulations. She said, my job is to make sure no one dies. I thought that's a pretty cool, that's someone who understands their mission, right? That's someone who understands what they're about. So in her mind, the regulatory stuff wasn't, can we work within the rules? It was, I need to make sure no one dies, yeah? So we need to go and make friends with all of the stakeholders, okay? And you need to contribute to the product. I was working with in a trading company, in a very small team, and the team of developers was sitting in amongst the traders. And it was just as likely that a good trading idea would come out of the developers as out of the traders. And also over time, the traders learned Python, which is kind of cool. So they could now start trying things. And of course, they're not going to be great programmers, but they could say, here, look, I've put this thing together. I think it's a sort of idea. And then the developers could take that and go, that's a really cool idea. I'm going to go and run with that and turn it into something cool. And so we can start cross-pollinating. You want to start blurring the edges of what it means to be a programmer versus a domain expert versus a user. So these are some things to think about when you're thinking about yourself as building a product. But there's more, right? So this product doesn't exist on its own. It's on a platform. Okay, so what does it mean then to be building stuff on a platform? Well, so the first thing is this, is you need to understand the technical landscape that you're in. So that means going out into the organization and figuring out what's there. Right? Try not to reinvent the wheel and try and understand what's out there. This morning I was saying one of the anti-patterns is these kind of enterprise mandates where you have to use a platform. But it's just as much of an anti-pattern to not know what's out there and keep reinventing it time after time after time. One guy I know has been in the same bank for something like 20 years, and he's seen the same platform written 6 times. I don't know why you would write the same platform 6 times, but every time there's a really good reason, right? And every time it's a better reason than the previous time, and every time it's not the same reason. It's the same reason every time, okay? It's usually a new CIO comes in and they say, let's have a new thing. You need to understand the path to production. Every organization has a different path to production. In most organizations, it's eye-wateringly bad. I was working with a retailer in the UK, and we did a bet. We bet that we could build something in 90 days. And this is a very traditional kind of development environment where they were planning years, you know. Typically, this one product, the first release was going to be after 18 months. And I said, I think we could ship something meaningful in 90 days, or 3 months. And they went, no, don't be silly, you can't do that. So I challenged them. I said, if we could, what would it be? And we locked ourselves in a room for a couple of days, and we came up with the thing we could build in 90 days. And we went ahead and we built it in 90 days, and we had something substantial at the end of 90 days. And it was really cool. I said, great, now we just need to release it. Guess how long it took to release it? Another 90 days. It took another 3 months from we're ready to go live before it was live. Okay? Because it was just an eye-watering path to live. And none of this was technical. This was all process and meetings and coordination and sign-offs and checklists and just what's called organizational scar tissue. So things that people had added again and again and again over time just in order to try to make sense of things. So if you understand the path to live, the path to production, then you can start to reason about the platform you're on. You need to care about runtime concerns. You don't just build it and then ship it. Okay, so again, your users, your operators, operations are first-class users. So, so with runtime, I think of runtime as particularly monitoring as 4 levels. In fact, there's 4 levels and there's 2 bonus levels. Okay, so your first level is this. It's called instrumentation. So instrumentation is the ability of something to be measured. Okay, it's observability. So instrumentation is, is it possible to get data out of this thing? So the next thing is called telemetry, and telemetry literally means measuring at a distance. So tele means distance, like television and telescope, and metry is measuring. So telemetry is measuring at a distance. So that means that I can get these measures and I can send them somewhere. I don't care whether your measures, whether you send stuff out or whether people come and pull them. So whether you're emitting messages or whether people are kind of scraping those messages, I don't care. But you need to be creating the messages and sending them out. So instrumentation, telemetry. Then I want monitoring. So monitoring is now someone is listening to those messages. So you create the message, you send the message, someone receives the message. But monitoring gets really boring really fast, right? So you're watching a screen where mostly nothing happens, ideally, yeah, which is really dull. So the next thing I want is alerting, right? So once I have instrumentation, telemetry, monitoring, alerting, I've basically got a deployable stack. And this is your table stakes for anything like microservices or like distributed systems. You need all those things in place. For extra credit, the thing we want above alerting is then machine learning. Okay, it's predicting. So is it Netflix has a wonderful model they have so that they've been modeling their own usage patterns over time, and there's this wonderful graph of like demand, and they've now used machine learning to track what their demand's going to be and preemptively spin up instances, and also when they think demand's going to go down to preemptively reduce the instances. And they have these graphs, and literally the lines are basically tracking each other. So their prediction line and their usage line are almost the same. And they said, we don't know why. We don't know why it's suddenly going to go up there or down there. I mean, sometimes we do, but mostly we're guessing. But what we do know is that the model's really good, and so we trust it. And they've saved, hundreds of thousands or millions of dollars of operating costs by being able to scale up and down just ahead of when it was needed. So level 5 out of 4 then is predicting, and then level 6 is the really cool one, is self-healing. Right? If I can measure when things are going wrong, predict when they're going to go wrong, and I've got some software, why should they have to go wrong? Right? And you can start doing preemptive healing. But if you can just get those first 4, instrumentation, telemetry, monitoring, alerting, you're going to go a really long way to being able to make sense of your platforms. Okay. As a platform concern, you value automation. Okay, so automating things means that we don't have humans doing them, which means that we free up those humans to do much more interesting things. It means that things work faster, and it means that there are much fewer errors. So we value automation, but not all the automation. Okay, I used to be very much automate everything. Right, automate everything. If it's possible to automate it, we should automate it. Not so much anymore. My heuristic for this is this: automate things when they're boring. Okay, when something's boring, you get to automate it. Boring means 2 things. First thing it means is this: we've done it enough times that it's boring. Okay, so don't automate something the first time, or even the second time, or maybe the third. By about the 5th or 6th time, you might want to think about automating it. The other thing that boring means is it's been the same all of those times. If every time you do something, it's a little bit different, and a few surprises in there, right? Then A, figure out what the surprises are, because that's not good, and also don't automate yet, because you can't automate for all those surprises. So once it's been the same a whole bunch of times, then it's a candidate for automation. But don't be too keen to automate. Be aware of it, but don't make it, don't put it on a pedestal. So values automation, and again, now you contribute to the platform. Right, so this is now you as a more rounded individual. You're now contributing back. So you realize there was something that annoyed you. It's probably annoying everyone else using that platform. And so you contribute back. Gojko Ajic, who's one of my favorite, he's a crazy Serbian programmer. He came up with specification by example. He's written loads of wonderful books. And event mapping. No, impact mapping. So he's built a web app called MindMap. And MindMap is a web-based mind mapping tool. And part of MindMap, writing part of MindMap, he wanted to use Amazon Lambdas, AWS Lambdas. And so he's using Amazon Lambdas, and he realized that he was writing, so he'd write this much JavaScript code, Node.js code for the Lambda, and this much stuff to get the Lambda running. And the whole thing about these Lambdas are super easy and lightweight and free and whatever else. That's great, except he had all this problem here. And so he wrote a little app for himself called Cloudia, which is Cloudia.js, which automates all of this into just a little command line thing. And so now you have the code that you want to write and a little command line tool and some configuration. And it turns out this is now the most popular serverless online tool. Sorry, the most popular serverless open source tool in the world. And he's now become Mr. Serverless. And this was not his plan at all, right? He contributed back to the community, and he's suddenly got this. He's suddenly this very prominent character. So contributing back to the platform. And there's more, because you're in a department. Okay, so what does that mean? What does it mean to be in a department? It means that you understand the wider concerns and the wider context. Okay, so there's a bank, Goldman Sachs Bank. When you join Goldman Sachs, apparently, as a graduate, they say there's 2 things we care about. We care about impact and influence. And impact is how much stuff you do, your own personal contribution. Influence is what you get other people to do. So early on in your career, when you're what's called an IC, an individual contributor, it's mostly about impact. It's what do you do? Are you a great programmer? Are you a great analyst? Are you a great project manager? Whatever it is you're doing. But then over time, as you move up through the ranks, as you become more senior, it's much more about what you can do. So if I can reach a room full of 100 and something people, a couple of hundred people, and give you a message, I've just got a multiplier of 200. Woohoo! Right? If I go off and try and do that on my own, even if I'm really, 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 really fast at doing stuff, there's one of me. Yeah? So influence is a really important thing. If you can radiate ideas out, which is why blogging, right? Blogging, because then your ideas get shared by other people and they get picked up by other people. And what I find, which makes me very happy, is they get improved by other people. So I'll throw a half-baked idea out there and it will go around and it will come back to me as a much better thing. And I'm like, I would never have thought of that. That's fantastic. I wish I'd thought of that. That's really cool. I'm going to steal it. Pretend it was, no, I'm not going to pretend it was mine. But so this is what we need to think about, is we understand the wider context and we start contributing to that. So I need to understand now that I'm not on my own. I'm not working in isolation. So I need to make trade-offs. So I don't just go and use cool new tech because it's there. I look around and I see what other people are doing and I plug into that. A chap I know at a bank in London found it really difficult to find out what other people were doing. And he figured that maybe other people would find it difficult to find out what other people were doing as well. And so he created communities of practice within the bank. And it was really simple. He just went and asked the Microsoft Exchange team. He said, can you just set me up some mail lists just for some people? So he set up a developers one, and he set up an agile one, and about half a dozen of these things. And then before he knew it, within a few months, 7,000 of his peers, 7,000 other developers right the way across the bank were now using these communities of practice. Okay, so it turns out that his pain was being felt by loads of other people, and so now these communities of practice became channels through which people could share and people could learn, which was very cool. You need to try and share knowledge across the teams. Okay. So not just communities of practice, things like learning lunches, things like meetups, things like brown bag sessions, that kind of stuff. So you get people together and you show things off. We've had some live coding today. We've had some brilliant knowledge sharing today. Obviously, I can't be in 2 rooms at once, but every single talk I've been in, I've learned something. And every single talk, someone has really prepared and really thought about what they want to share with the community. And that's really important. And all the knowledge. So early on in my career, I was a contractor in the late 90s. I was working as a contractor in London. And it was my first time I'd ever been a contractor. And what I realized was there were 2 models of contracting that basically work. One is that you hoard all the knowledge. Okay? You become the only person who knows something. There's one friend of mine was a DBA. And he was a DBA who was a contract DBA, so he's supposed to be there as a temp. He was a contract DBA, and he had had 5 permanent managers since he'd been there. Okay, he'd been there for quite a few years, and basically a number of permanent managers had joined the company, moved on or left or whatever. He was still there, right? So he's hanging on to this knowledge, and that made him indispensable. That's one model. The other model is you share all the knowledge. And you have to decide fairly early on which one you're going to be, and I decided fairly early on which one I was going to be. I've found that I have much more fun sharing all the knowledge. Because if I share all the knowledge, someone says, oh, thanks for that. Can you come and help with this other problem now? Because loads of people know how to do that thing that you did over there. So can you come and do this new interesting thing? So I get to go and do new interesting things. Whereas if I hoard all the knowledge, I only ever get to do that one thing, which is pretty dull, right? It's probably quite lucrative, but I don't want to live that life. I'd much rather be having fun. So share all the knowledge. Blogging, talking, getting out there, sharing, and learning as well, yeah? You're contributing to the department. So this is now, how do other departments see us? Okay, how can I start influencing across the organization as well as within my area of reach? And how do I influence up and down as well? Okay, and then finally, you influence across the organization. Yeah. So this is your reach. This is your impact versus influence. This is now when you flip it and you become the influencer. So how can we take good practice and make that normal everywhere else, because it makes everyone's life better? But also, how can I go out and learn what's going on and harvest those good ideas and make those successful as well? The best enterprise architects I know don't come up with anything of their own. Their job is to go around, find out what people on the ground nearest the work are doing, get excited about it, enthuse about it, bring it back in, and then project it out. They say, oh, this thing that Pavel did this really cool thing, and I want people to know about it because that's cool. Okay, yeah, Wojciech did this really cool thing, and let's go and make it popular. So then finally, you're in an organization, and what does that mean? That means that you project the organization's values. Would you proudly, here's an interesting question, would you proudly wear a t-shirt that had your company's name on it? Okay, or are you slightly embarrassed about that? Because you should ask yourself why, right? And why are you working there? If you would be embarrassed to wear your company's logo on a shirt, right? Why is that? Yeah. So you project the organization's values. Every organization has values. It usually isn't the ones that are on the wall or the ones that are on the fancy poster in a head office. That's not their values. Their values are how they act. So if they act with integrity, then they value integrity. If they act subversively, then they value subversiveness. Yeah. If they act honestly and openly, then they value openness and honesty. Right. So look at how the organization acts. How well do those values align with your values? If just by living your life and being authentic, you're projecting their values, you're probably in the right place. Conversely, if they're not, maybe try and change the organization. And as the saying goes, if you can't change your organization, change your organization. Right? As Martin Fowler said that, I like that. You care about the organization's reputation. It matters to me if I hear someone bad-mouthing my company, that I step in, I say, just a minute, I think you're being a bit mean there, because, what we do is da-da-da-da. I happen to work there and I want to defend it. Right? Not in a bar when everyone's been drinking, because that's just, but do you know what I mean? You care about the reputation. And you share your knowledge externally. Okay, this whole event is put together by one company. I think that's pretty cool. Right, I think that's pretty cool. And they haven't been up here going sell, 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 or buy, 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 buy. They've been coming up here going share knowledge, get a bunch of smart people in a room, hang out. Yeah, I love events like this. Not all their knowledge, clearly. Right? There's IP concerns. Yeah. So be aware when you are out speaking on behalf of your company that you are speaking on behalf of a legal entity, and particularly if that legal entity has, very, very valuable IP. Be aware of the language you're using and be aware of what it is you're saying, because, well, as they say, what happens in Vegas ends up on YouTube, right? So do you know? Yeah. And again, though, but you contribute to the organization. So you do stuff that matters to the organization that's above and beyond what you do. So many really cool initiatives start off as someone's hobby. Gmail, for instance, started off as a couple of Google geeks saying, right, Microsoft Exchange sucks, we really hate, or whatever mail client they were using, or Lotus Notes or something. We hate using this thing where Google, let's reimagine email as a search problem. Because basically email is a search problem. So if you reimagine email as a search problem with a web app, you get Gmail. Okay? So they went off and hacked this. And then it became, over time, the way that Google does its own internal mail. So Google runs on Gmail, which is kind of cool until you get a total Gmail outage and then no one can communicate with anyone. But that's a story for another day. So you contribute to the organization. Okay? So you are a developer in a team, building a product on a platform, okay, in a department, in an organization. Right? There's many, many dimensions of you. You are beyond developer. Okay? So I just want to leave you with one of my favorite quotes, a poet called, this is a different quote. If you want to go fast, go alone. Right? If you want to go far, go together. And I have an addition to this, which is, if you want to go far quickly, travel light. Okay? So what you want is to get a small group of people who are all passionate about the same thing, work in an agile way, care about your stakeholders, care about what you do, care about your own reputational, about your own reputation as well. Get out there, get excited about things, okay? Be passionate about things, share all your toys. because sharing all your toys comes back to you many, many, many fold. Thanks very much.